going to talk a little bit about uncertainty today. So, uncertainty arises from the fact that we can never make completely exact measurements, can never be completely accurate. There's always a degree of uncertainty in those measurements, hence the name. Um, Now, this can come from a few different things. One type of uncertainty or error, those words are interchangeable, systematic uncertainties. Now, this comes up from, say you have an issue with your, say like you're doing a measurement and your device, whatever you're using to measure, is not calibrated properly. So you'll constantly have inaccurate results. So arises from measurement for equipment in general, like your environment, you could say, issues. Like for an example, one that wouldn't come from an equipment issue is if you're trying to measure a magnetic field or something like that, and you don't take into account the Earth's magnetic field in your measurements, because the Earth's magnetic field would interfere with your measurement. If you don't take that into account, then you'll always be off by a little bit, and that would be your systematic uncertainty. In other words, you could say that the uncertainty is always the same in a way. Like you have the same issue every time. Kind of the opposite of that is random error. So everything, the world works where everything is not the same every single time, right? You can do something, you could kick a soccer ball one way first time, try to do it the same the second time and totally mess it up, right? There's random error. Um, so this is not systematic, but randomly occurring. And that's just a natural thing with doing multiple measurements. So, how do we look at uncertainty numerically? Well, I'll just do an example here where, say, somebody runs 50 meters. You measure them running 50 meters, um, but maybe your tools for measuring, they're not completely accurate, and they definitely wouldn't be. Uncertainties arise in all measurements. Now, based on your tools, let's say you're uncertain within 2 meters. So what this is saying is, well, we add this plus or minus to say we're uncertain within plus or minus 2 meters. And what this is really saying is if you minus 2 from the 50 and plus 2 from the 50 meters, you get this range. And what that's saying is when you write out like this, you're saying they ran 50 meters, but I don't know if maybe they ran 48 meters or 52 meters. Based on your measurement, there's a range in which the answer really could have been. So they could have ran anywhere between 48 and 52. So that's how we express uncertainties as a range of values that we don't know. So with another example, say with that tells us something about the precision of a measuring device, such as a ruler. If you measure on a ruler and say you hit this point, you measure 0.5 centimeters is what this would be. Um, what's the uncertainty here? Well, we can look to the precision of this device and say, okay, the smallest increments we have are 1 millimeter. So this is 1 millimeter, 2 millimeters, 3 millimeters. Beyond that, it's just empty space, right? And so that would be our uncertainty. We can't know if we measure, say, in the middle here, we can't say for sure um, whether that is, what is this, 1.1 or 1.2. We can't say this is 1.1 0.1257, right? That's too precise for this device. So what we do is we take the smallest increment, which would be a 1 millimeter increment, and use that as our uncertainty. So that's the width of our uncertainty. So how this would look is if we measured this zero point 0.5 centimeters. In fact, I'll write it in millimeters instead for to make it easier. 5 millimeters. This would be plus or minus half that, because plus or minus half of this would equal 1 millimeter, which is the increment, the smallest increment of the device. So that's how you do uncertainties with measuring devices. And now I think one final thing, um, just to go through uncertainty, different ways we can express uncertainty. How I've been doing it so far, showing you, is I'll have, let's do this example again, the 50 meters plus or minus the 2 meters. This is the actual distance value. And that's probably the most common way to express your uncertainties is in the actual value. But you could also, if you want to express this in terms of a percentage. So let's say someone runs 100 meters and we're really uncertain within 10 plus or minus 10 meters. So that's saying again, this person could have run 90 meters or 110 meters or anywhere in between. A way we could express this instead of in its actual value is in a percentage value of this value. So you could say the distance is 100 meters and 10 is 10% of 100. So you could say plus or minus 10%. So that's just a different way you can express it. This and this, they're both perfectly valid. In my opinion, I like to represent it in this, in the exact value, the actual value, because it just makes more sense to me in my head. But there are cases where you want to express in terms of percentage, and even in the next video, we'll look at those cases. Um, so that's just an intro to uncertainty. Really important to know. Um, and yeah, that's that.